This conference will now be recorded.
Good evening. In yesterday's class, we have discussed how to evaluate definite integrals. Now we see few more problems based on few more problems of the same type. Okay. Definite integrals will have the limits, upper limit and lower limit, right? Now see this problem. Evaluate integral pi by 6 to pi by 3. Evaluate integral pi by 6 to pi by 3. 1 over 1 plus square root of tan x dx. 1 over 1 plus square root of tan x dx. How to evaluate this? Here the lower limit is 5 by 6 and the upper limit is 5 by 3. Okay. First, we have to simplify the integrand because we have tan x in the denominator. So how will you write tan x? Tan x is sin x by cos x. So you will have integral dx by square root of 1 plus sin x by integral dx by 1 plus square root of sin x by cos x. Okay, square root of sin x by cos x. Now cross multiply. So you will have square root of cos x plus square root of sin x in the denominator, and square root of cos x will come to the numerator. So now this is your integrand. This will be your. Okay. Now I am going to use properties of definite integrals. The last class we have studied some of the properties of definite integrals. Yes. What is property number 3? This property number 3. Integral 0 to a f of x dx. Integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. We are going to solve this problem based on property 3. We are going to use property number 3, integral a to b f of x dx. Integral a to b f of x dx is integral a to b f of a plus b minus x. Okay, that's what property number 3. Property 3 is integral not 0 to a, because here it starts from pi by 6 to pi by 3. Okay, no 0 here. So this is how the form integral a to b, where a and b are upper and lower limits. X belongs to the closed interval a comma b. Okay, integral a to b f of x dx. Then integral a to b f of a plus b, sum of upper and lower limits, minus x. So wherever you have x, you have to replace it by a plus b minus x. And then we have to integrate with respect to x between the limits a and b. That's what property number 3 says. Property 3 is integral a to b f of x dx is integral a to b f of a plus b minus x dx. Okay, so here what is a? A is pi by 6 and b is pi by 3. Okay, therefore integral pi by 6 to pi by 3 f of a plus b minus x. That means function of a plus b minus x. Actually, the given problem is a function of x. Now I am going to change it as function of a plus b minus x. Function of a plus b minus x. For that, what I have to do? I have to replace x by a plus b minus x. Okay, so what is a plus b? A plus b means pi by 3 plus pi by 6 minus x. So wherever you have x in the integrand, you have to replace it by pi by 3 plus pi by 6 minus x. This is what a plus b minus x. Okay, so replace it, divided by square root of cos of pi by 3 plus pi by 6 minus x plus square root of sine of pi by 3 plus pi by 6 minus x. Okay. Now simplify cos of pi by 3 plus pi by 6. What is the common denominator here? The common denominator is 6, right? So what will have? Cos of, here we should multiply the numerator by 2. So 2 pi plus pi. Okay, 2 pi plus pi. 2 pi plus pi minus x. What is 2 pi plus pi? 2 pi plus pi is 3 pi. 3 pi by 6 is pi by 2. So cos of 90 minus x. Numerator, what you are getting is cos of 90 minus x. After replacing, we are simplifying. Okay. So here the common denominator is 6. So in the first term, we have 3 in the denominator. So we need to multiply the numerator by 2. So what you will get? 2 pi plus pi divided by 6. 2 pi plus pi is 3 pi. 3 pi by 6 is pi by 2. So pi by 2 minus x. What is cos of 90 minus x? It is sin x. Okay. So you will get square root of sin x in the numerator. Divided by square root of, again this is cos of pi by 2 minus x. What is cos of pi by 2 minus x? Again it is sin x. Here if you simplify, then you will get cos sine of, actually you will get sine of, this is pi by 2 minus x, right? Sine of pi by 2 minus x. What is sine of 90 minus x? Cos x. So you get square root of cos x with respect to x. You simplify this, then again you will get pi by 2. So sine of 90 minus x is cos x. So what is the integrand now? Square root of sin x divided by square root of sin x plus square root of cos x. Now add 1 and 2. What is 1? Equation 1 is I equal to integral pi by 6 to pi by 3 square root of cos x by square root of cos x plus square root of sin x dx. Equation 2 is I equals integral pi by 6 to pi by 3 root of sin x by root of sin x plus root of cos x dx. Since the denominator is same in both the equations, we are adding, okay, so that we can simplify it easily. Adding 1 and 2, we get I plus I. In the left hand side, you will get 2i. In the right hand side, you will get integral pi by 6 to pi by 3. Add these two things. What you will get? The numerator root of cos x plus square root of sin x. Okay. By the denominator is common. So root of cos x have same denominator, right? So root of cos x into root of sin x respect to x. So if you add equation 1 and 2, then in the right hand side you will get this. Here the numerator and denominator are same, so we can cancel. If you cancel, then you will get 1. So integral dx. Integral dx is x. Between the limits pi by 6 to pi by 3, substitute the limits. How will you substitute? You have to substitute it for x. How will you substitute? Upper limit minus lower limit. Upper limit is pi by 3 minus lower limit is pi by 6. Simplify. The common denominator is 6. So here I have to multiply pi by 2. So we will get 2 pi minus pi. This 2 pi minus pi, it is pi by 6. 2i equal to pi by 6. Therefore, what is the value of I? I equal to pi by 2. Hence, we have evaluated the given integral because this is the given integral. I is the given integration. So we have evaluated the value of the given integral. It is pi by 2. Okay. I is the given problem. Is it clear to you all? Have any doubts in this problem? Now I move on to the next column. Evaluate integral 0 to pi by 2 log sin x dx. Evaluate integral 0 to pi by 2 log sin x dx. Okay. Here we are going to use property number 4 because see the limits. Here the limits are 0 and pi by 2. Lower limit is 0 and upper limit is pi by 2. Therefore, the given integral is of the form integral 0 to a. Integral 0 to a f of x dx. Integral 0 to a f of x dx. What is the property? Integral 0 to a f of x dx means then we can replace x by a minus x. Function of a minus x dx. That's what property number 4. If integral 0 to a f of x dx, then we can write integral 0 to a f of a minus x. If I have this form, if the given integral is of the form, then I can replace x by a minus x, the same limits with respect to x. Okay. So this property helps you to change the function from x to a minus x. Okay, what is a here? A is pi by 2. Now I am going to use this property. Integral 0 to pi by 2. Wherever you have x in the given integral, you have to replace it by a minus x. So what is a? Pi by 2. Pi by 2 minus x. So log of sine of pi by 2 minus x. This x is replaced by pi by 2 minus x. Okay, pi by 2 minus x. What is pi by 2 minus x? Sine of pi by 2 minus x. Sine of 90 minus theta is cos theta. So integral 0 to pi by 2 log of cos x dx with respect to. Now I am going to add these two. So I will get 2i in the left hand side. I plus I is 2i. That gives integral 0 to pi by 2 log sin x plus log cos x dx. I'm adding the left hand side as well as the right hand side. So in the right hand side, you will get log sin x plus log cos x dx. Okay. Here we are adding and subtracting log 2. Okay, I have added and subtracted log 2 here. Log 2 minus 2. Okay. So integral 0 to pi by 2. Here we have actually log sin x cos x plus log 2. This can be written as, this is of the form log a plus log b. Okay, log a plus log b. What is log a plus log b? Log ab. Log a plus log b is log ab. So you'll have log sin x cos x into 2. Log sin x cos x into 2. That means log 2 sin x cos x. Log of 2 sin x cos x. How will you write 2 sin x cos x? Here I have added log 2 and subtracted log 2. Okay, because here we have sin x cos x term. So if I add log 2, then I can combine these two. Okay, if I combine these two, then I will get sin 2x because sin 2x formula is 2 sin x cos x. This is of the form log a plus log b. So log ab. Log ab means log of 2 sin x cos x. Okay, 2 sin x cos x is nothing but sin 2x. So log sin 2x. Log sin 2x minus, here we can separate the integral 0 to pi by 2 log 2 dx. Okay, is it clear to you? So what we have got, integral 0 to pi by 2 log sin 2x dx minus log 2. We have combined the first two terms. This will give you, this gives log sin 2x, and we have minus integral 0 to pi by 2 log 2 dx. Next, we have to integrate the first integral because the second integral is very easy since log 2 is a constant. We have to integrate it with respect to x. Okay, so this will be easy. Now concentrate the first integration. Here we have integral 0 to pi by 2 log sine 2x dx. Okay, how to integrate this? By using substitution method. What substitution I am going to use here is 2x equal to t. Take 2x equal to t. To take 2x equal to t, then you will get 2 dx equal to dt. When you differentiate with respect to x, then you will get 2 dx the left hand side and dt in the right hand side. Next, we have to change the corresponding limits also. This is the lower limit of x 0. So when x takes 0, what is the value of t? Substitute x equal to 0 here. Your transformation. If x is 0 means t is also 0. Okay. Next, come to the upper limit. The upper limit of x is pi by 2. Substituted here. So you will get 2 times pi by 2. Cancelling 2, what are getting? Pi. So when x takes pi by 2, t is pi. T takes pi. Now the new limits are 0 and pi. So integral 0 to pi log this 2x can be replaced by t. Okay, log t. What is dx? Dx is from this dx is dt by 2. Dx is dt by 2. So substitute here dt by 2. 1 by 2 is a constant. Take it outside. Okay, so 1 by 2, 0 to pi log sine t dt. Okay, next I am going to use one more property. Since we have integral 0 to pi by 2, I am going to change the limits as 0 to, here I have 0 to pi. So I am going to change the limits as 0 to pi by 2. For that, we have to multiply this by 2. That's what property number 6. Okay, so integral 0 to a is 2 times integral 0 to a by 2. So 2 times integral 0 to pi by 2 log sine t dt minus pi by 2 log. This property number 6. Go to property number 6. What it says actually, integral 0 to 2a f of x dx. 2a f of x dx means 2 times integral 0 to a f of x. In that problem, we have integral 0 to a f of x dx. So 1 by 2 integral 0 to 2a f of x dx. If f of 2a minus x equal to f of x. Okay, so we are going to use this property 0 to a. 2 times 0 to a means 0 to 2a. So what is that property? Integral 0 to 2a f of x dx is 2 times integral 0 to a f of x dx. If f of x is f of 2a minus x. This is the condition. If f of x equal to f of 2a minus x. Okay. So here we have integral 0 to 2a. What is 2a? 2a equal to pi. In place of 2a, we have pi. Okay. Therefore, a value is pi by 2. A value is pi by 2. So 2 times integral. Already we have 1 by 2 outside. So 1 by 2. 2 times integral 0 to pi by 2. Okay. Integral 0 to pi by 2. Provided sine of pi minus t is equal to sine t. this condition should be satisfied. Okay, f of x equal to f of 2a minus x. What is your f of x here? F of x is sine t. The function is sine t. So sine t equals f of 2a minus x. What is 2a? 2a value is pi. Okay, so sine of pi minus t. You need to check that whether these two are equal. Then only we can apply this property. Is it clear to you? What is the property? Says integral 0 to 2a f of x dx equal to 2 times integral 0 to a f of x dx. Okay, integral 0 to 2a f of x dx means then I can write 2 times integral 0 to a. In the place of a, in the place of 2a, I'm having pi. Integral 0 to 2a. Here we have integral 0 to pi. So compare these two integrals. You identify what is your a. Here we have 0 to 2a. In the problem we have 0 to pi. Okay, so compare these two integrals. From this it is clear that 2a is pi. 2a is pi means a value is pi by 2. A value is pi by 2. What is this? This can be written as 2 times integral 0 to a. So 2 times, already we have 1 by 2. So 2 times integral 0 to a. What is my a? Pi by 2. So 2 times integral 0 to pi by 2. Already I have 1 by 2 here. Okay. Provided when I can use this property, provided this condition is satisfied, f of x, if f of x equal to f of 2a minus x. Okay, what is your f of x? Sin x or sin t? Okay, sin t is equal to, now replace t by 2a minus t. T by 2a minus t. What is 2a? 2a is pi. So pi minus t. Okay, you will get sine of pi minus t. What is sine of 180 minus theta value? It is sine theta. Both are equal. Sine t is equal to sine of pi minus t. Therefore, we can use this property. Now cancelling 2, you will get integral 0 to pi by 2 log sine t, cancelling 2, integral 0 to pi by 2 log sine t dt minus pi by 2. What is the first integration? This is the first integration. Second integration is 0 to pi by 2 log 2 dx. Here log 2 is a constant, so take it out. Integral dx. Integral dx is x. Integral dx is x. Substitute the elements 0 to pi by 2. Here log 2 is a constant, take it out. So integral dx is x between the limits 0 and pi by 2. Substitute the limits, upper limit minus lower limit. So pi by 2 minus 0. Pi by 2 minus 0 is pi by 2. So minus pi by 2 log. So what I am getting is 0 to pi by 2 log sin x dx. Changing the variable t to x. T is a dummy variable, so we have changed t into the original variable x. What is this? This is nothing but your problem. So I minus pi by 2 log 2. Okay, I minus pi by 2 log 2. Now bring this I to the left hand side. So you'll get 2i minus I is I. I is again 0 to pi by 2 log sin x dx. Bring this I to the left hand side. Already we have 2i in the left hand side. So we'll get 2i minus I. 2i minus I is I. I is nothing but 0 to pi by 2 log sin x dx. This value is minus pi by 2. So that is your one. More exercise problems are given. Go through it. And in this section, miscellaneous examples, some different types of problems solved here. Since we are discussing definite integrals, we see problems based on definite integrals. Yes, this is a definite integral. Since we have limits here, evaluate integral -1 to 3/2 absolute value of x into sine pi x dx. Modulus, the absolute value of x into sine pi x dx. So absolute value, if the integrand is in terms of absolute value or in terms of modulus, then we need to check that the given function is whether the given function takes positive values in the given range or it takes negative values in the given range. That we have to check here. Okay. In what intervals it takes positive values, it takes negative values, that we have to check. Here the lower and upper limits are -1 and 3/2. This x belongs to the closed interval -1 comma 3/2. -1 comma. Here the interval -1 comma 3/2 is divided into two subintervals, namely -1 comma 1 and 1 comma 3/2. Okay, in -1 comma 1, the function takes positive values. That you can check by giving values for x. Now substitute x equal to -1. What do you get? -1 sine pi x, right? So sine minus pi. This x is -1. Sine of minus theta is minus sine theta, so it becomes plus. So sine pi. Sine pi value is 0. So you have to check the next value. Then check in between value, say 1/2. Okay, -1/2. For -1/2, whether it takes positive value or negative value, that you can check. -1/2 means -1/2 sine of -5/2. We are putting x equal to -1/2. Sine of -90 is minus sine 90, so it becomes plus. So 1/2 sine 90. Sine of minus theta is minus sine theta. So already we have minus, that becomes plus. 1/2 sine pi/2. Sine pi/2 value is 1. So you'll get 1/2. It takes positive values. So in this range, modulus x sine pi x takes positive values. So x sine pi x. Similarly, now to check in this range, 1 less than or equal to x less than or equal to 3/2. You substitute x equal to 1. What do you get? -1 sine pi. Okay, -1 sine pi. -1 into sine pi. Sine pi value is 0, so entirely 0. Then you check 1/2. 1/2 means -1/2 sine pi/2. Sine pi/2 value, we know it is 1. So what you're getting is -1/2. Yes, we are getting negative values. So in this range, the function takes negative values. So minus x sine x. Okay. So the given integration is separated into two subintervals. The given interval is divided into two subintervals. Therefore, the given integration also can be separated into two integrations. Integral -1 to 1 plus 1 to 3/2. In -1 to 1, the function is x sine x. Okay. In 1 comma 3/2, the function is minus x sine pi x dx. So integral -1 to 1 x sine pi x dx minus integral 1 to 3/2 x sine pi x dx. Now we have to integrate both sides. Sorry, both integrals. Okay. Integral -1 to 1 x sin pi x dx minus integral 1 to 3 by 2 x sin pi x dx. Now consider the first integration. To integrate, what you will get? Here we have to apply the integration by parts method. Okay. What is u? U can be taken as x. This is how the form integral u dv. Okay. So u is x and dv is sin pi x dx. Sin pi x dx. So what is u dash? U dash is 1. What is v? Dv is sin pi x dx. So what is v? V is, you integrate this, what you will get? Minus cos pi x. Minus cos pi x by, what is the constant? Okay, now you substitute all these things in the formula. What is the formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. This is the Bernoulli's formula. You substitute it here. What is u? U is x. Okay. Here they have substituted u is x. V is minus cos. So minus cos pi x by pi. Okay. uv minus integral v du or minus integral u dash v1. You can either apply Bernoulli's formula or you can go for u du. So minus u dash. What is u dash 1? So minus 1 v1. What is v1? So we have to integrate v. v1 is minus uh, integral cos pi x is sin pi x. So sin pi x, already we have pi. So this time if you integrate, then you get pi square. So minus minus plus minus u dash. So you have plus sin pi x by pi square between the limits -1 and +1 minus this integration. Now again uv. So u is minus x. Sorry, u is x and v is minus cos pi x by pi minus u dash. v1 also we have minus, so it becomes plus sin pi x by pi square between the limits 1 and 3. Okay. Here the function is same, only the limits are different. Right? So now substitute the limits. You substitute the upper limit, then what you will get? Cos pi. Okay, cos pi is, what is the value of cos pi? It is -1. Okay, so -1 we are substituting for x. So -1 cos pi. Cos pi value is 1. So -1 by pi plus this term will become 0 because sin pi x is 1. You substitute x equal to 1 here, then you will get sin pi. Sin pi value is 0. So -1 cos pi divided by pi. This is the upper limit minus lower limit. Okay. So what will get? -1 by pi, the upper limit, minus lower limit. Again substitute x equal to -1. -1 minus of -1 is +1. So 1. Again cos pi of -1. Cos of minus theta is cos theta. So cos pi divided by, here if you substitute -1, sin pi is actually 0. So this will become 0, right? So 1 minus cos pi minus 1 by pi minus cos pi. So what are you getting? -1 by pi. This is also minus 1. The lower limit, this is 0. Now come to this. If you substitute the upper limit, then you will get cos pi x. X is 3 by 2, right? 3 by 2. That is cos 270 degree. 3 pi by 2 means 270. So cos 270 value is 0. Cos 270 degree is 0. But sin 270 degree is minus 1. Sin 270 degrees minus 1. So this becomes 0 in the upper limit. And in the lower limit, this is minus 1. Already we have minus outside. So plus 1 by pi square. Plus 1 by pi square. This is 0. This is minus 1. Already we have minus. So plus 1 by pi square. Next in the lower limit, this will become 0. Okay. You will get plus here. Minus x. So minus 1 cos pi. Cos pi value is minus 1. So it becomes plus 1. If you simplify, then you will get 3 by pi plus 1 by pi square. That's the answer. The next problem is evaluate integral 0 to pi x dx by a square cos square x plus b square sin square x. Okay, we have x in the numerator, denominator a square cos square x plus b square sin square x. See the limits, it starts from 0 to pi. So it is of the form integral 0 to a f of x dx. Integral 0 to a f of x dx. What is the property here? If integral 0 to a f of x dx, then we can replace x by a minus x. That's what property number 4 says. If integral 0 to a f of x dx, then I can replace x by a minus x in the limits 0 to a. So wherever you have x, replace it by a minus x. What is a here? A is pi. So what is a minus x? Pi minus x. To replace it, this x to be replaced by pi minus x divided by a square cos square x is pi minus x plus b square sin square x is pi. So integral 0 to pi. Here we have two functions, pi minus x. So separated, pi divided by a square cos square of pi minus x plus b square sin square of pi minus x. Minus x divided by this. Here pi is a constant, take it out, integral 0 to pi dx by a square cos square x plus b square sin square x. And this one is actually the given problem. Plus I, so minus I. Bring this I to the left hand side, it becomes 2. So 2I value is pi integral 0 to pi 1 over a square cos square x plus b square sin square x dx. Therefore, I is pi by 2 integral 0 to pi 1 over a square cos square x plus b square sin square x. Again, by property number 6, this can be written as 2 times integral 0 to pi by 2. Okay, integral 0 to 2a f of x dx is 2 times integral 0 to a. Integral 0 to 2a. F of x dx is 2 times integral 0 to a. Okay, so in the place of 2a we have pi. 2a is equal to pi. Therefore, a value is pi by 2. Okay, so 2 times integral 0 to pi by 2. 2 times integral 0 to pi by 2. Already we have pi by 2 outside. 2 times integral 0 to pi by 2, 1 over a square cos square x plus b square sin square x plus 2 and 2 will get cancelled. So integral 0 to pi by 2 is written as 0 to pi by 4 plus pi by 4 to pi by 2. 0 to pi by 2 can be written as 0 to pi by 4 plus pi by 4 to pi by 2. Okay. How will you evaluate this integration? Here we have a square cos square x plus b square sin square x. So divide each term by cos square x in the denominator. So cos square x, here also cos square x. As well as in the numerator, we have 1 by cos square x. What is 1 by cos square x? It is secant square x. Here cos square x will get cancelled. So you'll have a square plus sin square x by cos square x is tan square x. So b square tan square x. Similarly, here I'm dividing by sin square x in the numerator as well as in the denominator, each and every time, sin square. So this is by sin square x. This cos square by sin square, cot square x. Sin square by sin square x is 1. 1 by sin square x is cosecant square x. So secant square x by a square plus b square tan square x, cosecant square x by cos square x plus b square. How to evaluate this? By substitution method, because we have uh, tan square x in the denominator. Differentiation of tan is secant. The differentiation of cot is cosecant, that is present in the integral. Okay, so tan x equal to t and cot x equal to u. Tan x equal to t means what is dt? dt is tan square x. Sorry, dt is t is tan x. So dt is secant square x. Differentiation of tan x is secant square x. Dx. So the secant square x dx is replaced by dt. Okay, by a square plus b square, tan square x is t square. Plus, here we have cosecant square x, right? So take u equal to cos x, cot x. U is equal to cot x. So differentiation of cot x is minus cosecant square x. Minus cosecant square x dx. So this cosecant square x dx is replaced by minus du. Okay, minus du divided by a square u square plus b square. We have to change the limits also. When x is 0, what is t? T is also 0, tan 0 is 0. When x is pi by 4, tan pi by 4 is 1. So 0 to 1. Here, when x takes pi by 4, now to substitute it here. When x is take pi by 4, what is u? U is 1. Cot pi by 4 is 1. When x takes pi by 2, what is u? Cot pi by 2 is 0. Cos 90 by sin 90. Cos 90 is 0, sin 90 is 1, so 0. Here I have minus 1 to 0. So I can change the limits from 0 to 1. If I change the limits, then I will add 1 minus. So it becomes plus. Or else you can evaluate it directly. This is how the form integral dx by a square plus x square. What is integral a square plus x square? 1 by a tan inverse x by a. Okay. So what is your 1 by a? Divide by b square. Here the variable is t, right? So we'll get 1 plus b square t square by a square. b square t square by a square. This is other form a square plus x square. A is 1. So tan inverse bt by a. 1 by ab tan inverse bt by ab. Similarly, here also you have pi by ab tan inverse au by b. Substitute the limits. In the upper limit, you will have tan inverse b by a minus tan inverse 0, 0. So tan inverse b by a. Here pi by ab is common, so take it out. The upper limit, this will become 0 because tan inverse au, u 0 means tan inverse 0, 0. Minus lower limit, so it becomes plus. Substitute the lower limit 1 for u. Okay, so tan inverse a by b. What are you getting? Tan inverse b by a plus tan inverse a by b. You simplify, then you will get tan inverse b by a plus tan inverse a by b is pi square by 2ab. How it becomes pi? This value is pi actually. Tan inverse b by a plus tan inverse a by b values by 2. Tan inverse b by a plus tan inverse a by b is pi by 2. That is one of the result. Into pi by ab. So you'll get pi square by 2ab. Here we have to apply what formula? Ex by a square plus x square. A square plus x square. So divide the entire term by a square. So dt by 1 plus b square a square. B square by a square t square. Okay. This is tan inverse x by a. This is tan inverse t by bt by a. X by a. Tan inverse x by a. No, you no need to divide. You can write it directly because we have a square plus b square t square, right? So tan inverse x by a. In the place of x, we have bt. So bt by x by a, right? So bt by here tan inverse au by b. No need to take the constants outside here. We can write it direct. Repeat the limits 0 to 1 and here 1 to 0. You want to change the limits, then you can change the limits here from 1 to 0 to 1. Then you have to add 1 minus, then it becomes plus here. Otherwise, you can do it directly from 1 to 0. Substitute the limits. This value is pi by 2. So you'll get pi square by 2. Any doubts of this? You have any doubts? If you have any doubts, you can ask me. If you have any doubts? Okay, then I will wind up this session. See you next class.